So to complete the loop-free topology, there's still a loop between switch 2 and switch 3 on E50 and E51. We have loop between switch 3 and switch 4 on E40 and E41, and we have a loop on between switch 2 and switch 4 on E42 and E43. What's it going to be? Well, the rule says first prefer the lowest cost of the path towards the root bridge. So let's consider that loop first. Switch 2 and switch 3. Switch 2, the lowest cost of the path is 100, and that's what is being advertised towards switch 3. Switch 3 root port is cost 100, and this is what's going to be advertised to switch 2. So there's a tie here. Switch 2 has the lowest cost of the path, 100, and switch 3 is also 100. They're equally or equidistant towards the root bridge. So the tiebreaker is the second step, which is the lowest MAC address of a switch, actually lowest bridge ID, but since I didn't change the priority of a switch, it's still 32769 on both. That means that the tiebreaker is going to be lowest MAC address of a switch. Switch 2, if you remember from the previous video, has a 1-2 identifier, and switch 3 is AABBCC0011. This is a lower. So 1-3, sorry. So 1-2 is lower. So this port should be designated port, and this port should be designated port. And let's verify that now. So switch 2 being the same distance towards switch root as switch 3, the tiebreaker is the lowest MAC address. Which MAC address on switch 2 is 1-2 versus 1-3. So 5051 should be designated port on switch 2. Let's jump to switch 2 real quick. Yeah, maybe clear the terminal. Okay. Show spanning tree VLAN 1 interface, and that is what? 50? Yeah, 5051. Ethernet 50 and 51, and both are designated ports, as you can see. So if both ports here are open and we have a loop, these two must be in a blocking state. So we must block those two ports on switch 3. Let's see if that's true. Switch 3, let's clear the terminal and show spanning tree VLAN 1 interface E50 and E51, and it's true, otherwise we would have a loop. Similarly, we have here switch 4 is sending BPDU's frames saying my cost towards the root bridge is 200, actually 100 here. So is the switch 3 sending towards switch 4. My cost to the root bridge is 100 here. So 100 plus 100 is 200. This guy says my cost is 100 received on this switch. 100 plus 100 is 200. It's the same thing. So the same rule, the second step is to prefer the BPDUs from the switch with the lower MAC address or lower bridge ID. Priority is the same on both. So lower MAC address is on switch 3. So switch 3 has 1-3 MAC address. Switch 4 has 1-4 AABBCC0014. This means that this should be 401 should be designated port on this end, on both ends, because BPDU come from both, and it's lower MAC address than here. So we should block these ports to avoid the loop. So if that's the case, let's see the switch 3 401. Switch 3 port E40 and 1, and it's designated ports both, just like I put in a diagram. So that means that these ports are blocked. So if I jump to same command on switch 4, let's clear the terminal. show spanning tree VLAN 1 interface E40 alternate blocking. And the last step here is the loop between switch 2 and switch 4. And the same rules, since both have 100 costs here, 100 costs advertised here, so 200 in total, advertised here 200 in total, the tiebreaker will be lowest MAC address. So obviously switch 2 has AABBCC0012 and this one has AABBCC0014. So these ports will be blocked and these will be designated ports forwarding traffic. And remember, not even BPD will come out of the on alternate port, which is in blocking state. So now 4, 2, 3 on switch 2 are designated ports. Let's switch to 4/2, 4/3, and the similar ports on 4, 4/2, and 4/3 will be in a blocking state. And that's how it goes. All the details you'll find in this blog in the lesson number 20. So ciscoiseasy.blogspot.com lesson 20 explains that in detail, but I showed you that in a different topology diagram which actually I use in the lab.